Today we are continuing with part 2 of our videos on multiplication and division of integers. This is the final part to our videos. Last week we started looking at multiplication and division of integers. We focused on how the multiplication works by breaking it down to repeated addition of sets of either positive or negative numbers, or repeated subtraction of sets of positive or negative numbers. This week, we are focusing on the division side of things. Before we get into the division, let's review the multiplication and division rules for integers. First, when multiplying or dividing two positives, the result is always positive. Next, when multiplying or dividing two negatives, the result is also always positive. And finally, when multiplying or dividing a positive and a negative, the result is negative. Remember, our rules for multiplying and dividing are the same no matter which operation we are doing. Now, let's jump into the division and use some models to illustrate why the rules work. Let's start with positive numbers because you are already familiar with them. We have 6 divided by 2. What does this expression ask us to find? It's asking how many sets of 2 will make a set of 6. Let's use our integer tiles again to start this off. As before, I'm going to begin with an empty box. The empty box represents 0. I don't have anything yet. Just as I did in the last video, yellow is going to be my positive and red is going to be my negative. Since both 6 and 2 are positive, I'm going to have all yellow tiles in this picture. So I have my 0, and now I want to add sets of 2 until I have a set of 6. Now I have one set, now I have 2 sets, and finally I have 3 sets. Our question was how many sets of 2 will make a set of 6. So here we can see 1, 2, 3 sets of 2 make a set of 6. So 6 divided by 2 equals 3. We can also show this on the number line. I know that 6 is what I'm trying to get to, and I know that that 6 is positive from looking at my original expression. Trying to get to positive 6, I want to add sets of 2 until I get there. There's 1 set added, 2 sets added, 3 sets added. How many sets did I add? I added 3 sets. So my answer is my positive 3. It took 3 sets of 2 to make a set of 6. Next, let's try an example with a negative and a positive. Negative 8 divided by 2. This time, our expression is asking how many sets of positive 2 will make a set of negative 8. Let's look at the number line first this time. I am trying to get to negative 8. But I have sets of positive 2. Now when I think about sets of positive 2, I think about moving in the positive direction from 0. But if I started adding sets of 2 like I did in our last example, we wouldn't end up with negative 8. We would end up with a positive 8, and we would never reach that negative 8. So how can we fix that? Remember last week, we had to repeatedly subtract or remove sets in the negative 2 multiplied by negative 3 example. Division being the inverse of multiplication, we can think of negative 8 divided by 2 as subtracting sets of positive 2 or adding sets of negative 2 until we reach that negative 8. I still want to indicate that these sets are positive, so as I'm adding them to my number line, I want to continue to have them go in the positive direction. So I've just added one set of positive 2, two sets of positive 2, three sets of positive 2, and four sets of positive 2. So here we can see that I have 4 sets. But what did I actually do to get those 4 sets? I didn't really add them, I subtracted them. Now we know from our number line above that it took 4 sets of 2 to make that negative 8. Because we subtracted, we put that subtraction or negative sign in front of the 4, letting us know that really what we were doing was taking away those 4 sets so that we could make it all the way to the negative 8 using our positive 2's. Let's try the same problem again, but this time with integer cubes. Again, our question is how many sets of 2 or positive 2 will make a set of negative 8? In our previous example of 6 divided by 2, we put pairs of positives into the box until we were able to reach that positive 6. Here, if I put pairs of positives in the box, I will never reach negative 8 because all of my integer cubes would still be yellow. So I need to put in pairs of negatives. Now let's stop and think for a moment. If I am finding how many sets of positive 2 make up a set of negative 8, how will that work if I only add sets of negative 2? What can I do to address the sets of positive 2 I am supposed to be finding? Remember in the multiplying, we used sets of positive and negative pairs when we were trying to remove things from our box. Could we do something similar here? Well, let's try. I'm going to start by putting in 8 negatives. Now I'm going to add in 8 positives that pair up with those negatives. Now I have put in my positive 8 and my negative 8, but in looking at my box, it looks like they're going to cancel each other out. When we have pairs of a positive and a negative, remember additive inverse says that they equal 0. I know I am trying to see how many sets of positive 2 make up negative 8. So let's go ahead and identify those sets of positive 2. I have 1, 2, 3, 4. Now, how can I get to a negative 8? I can do that by removing my sets of positive 2. So I've subtracted 1 set, subtracted 2 sets, I've subtracted 3 sets, and now I've subtracted 4 sets. By removing or subtracting 4 sets, I was able to get the set of negative 8 that I was shooting for in my original expression. So my result, negative 8 divided by 2 equals negative 4. Because I removed the 4 sets, it's taking them away, it's negative, so my answer is negative. Our final example, negative 12 divided by negative 4. Remember, I'm putting that negative 4 in parentheses just to distinguish it as keeping the negative and the 4 together and separate from that division sign. The expression is asking how many sets of -4 will make a set of -12. Let's use the integer tiles again. As always, I'm going to start with 0. Back in our first example, we were adding sets of 2 until we got to -6. Here, I want to add sets of -4 until I get to -12. There's my first set, my second set, and a third set. Now I have a set of -12. I got that by adding 3 sets of -4. You can see there's my 3 sets, and because I added them, my answer is going to be positive. Just like in the last example, we subtracted them from the set, so our answer became negative. Here, because we're putting the sets into the box, we're adding them, our answer is positive. -12 divided by -4 equals a positive 3. We can look at it on the number line as well. Here is my -12. This is the set that I'm trying to make from 0 to -12, and I'm figuring out how many sets of -4 will make up that -12. So I'm adding one set of -4, a second set of -4, and a third set of -4. Because I'm trying to get to -12 and I'm going in the negative direction, unlike the previous example, we are adding the 3 sets to get there. Before we were subtracting positives, this time we're adding negatives to get our negative. So our answer once again becomes positive 3 because we added the 3 sets of -4 to get to the 12. Once again, before we quit, our rules. A positive multiplied by a positive equals a positive. A negative multiplied by a negative equals a positive. And a positive multiplied by a negative equals a negative. That's it for today. I know these concepts of when to use repeated addition and when to use repeated subtraction can be difficult to remember and understand at times. As your teacher is trying to prepare you for the SBAC, it is important to help you understand why rules work, not just that they do, because you will need to be able to explain why your answers work on that SBAC, not just come up with the correct answer. That makes it really important to ask questions after these videos if you did not understand something. Please make sure you ask your teacher on Monday about anything you are not sure you get from either part of the multiplying and dividing integers videos.